We're at section 4.5, writing equations in point-slope form. Let's go. So the first question is, what is point-slope form? So we've already learned what slope-intercept is. Now we're going to learn a second equation called point-slope form, and this is kind of useful in certain situations. So this would be a linear equation of y minus y1 equals m, the slope, and then x minus x1. Is written in point slope form, where x1 and y1 are a given point on a non-vertical line, and m is the slope. So this works really well if you're given 1 point and a slope. If you're given those two things, you can punch into here and immediately get y equals mx plus b without having to use the slope thing that they've given you. Or to figure out the other way. So this is just a kind of a nice way to skip some steps, and we do need to figure out eventually how to switch them between point slope form and slope intercept. So those two are going to be our two main things for this entire chapter. Okay, so here's some just basic summaries here. If you're given the slope in 1 point, you simply substitute those three values in slope intercept form, solve for b, or use point slope form, which we just learned, and we're going to substitute the values of slope, and then x and y be x1 and y1. Then we write the slope intercept form using m and b, and we'll give you examples of this in a little bit. If you're given 2 points, you first find the slope using the slope formula. You choose one of those points, and then you follow the steps for writing an equation of slope in 1 point, which is over here. So find the slope, choose one of them, and use one of these two methods. All right, write an equation given a slope and a point. Write the slope point form of an equation for a line that passes through -2, 0 and slope of -3 over 2. So we take our point slope form and we punch all the numbers in. We substitute in the slope that they gave us into here. We put x over here and y over here. Substitute all three of those in. From here, now we have to distribute first. Oh, first they simplify. So there's the whole, simplify this out. Yep, that'll make life a little less complicated. Okay, oh, then that's it. Hey, look, it's already in that is the equation that we get. Use slope point form to form an equation. So that is the equation. That's as far as they want you to go just to get started. All right, try this one out. Go. All right, so we're going to take y minus y1 equals m, and then x minus x1. So my x1 is going to be 4. And my slope is -2. And then y minus y1 is going to be -3. And we should probably simplify that. So y plus 3 equals 2, and then x minus 4. There we go, letter B. Keeping going. Charlie is flying from San Diego to Washington, D.C., just like the East Coast trip did. Wait, they didn't go out of San Diego. Anyways, moving on. For vacation, after 1.5 hours, the plane traveled 810 miles with an average speed of 540 miles per hour. Write an equation of a line in point slope form. Okay, well, we're going to have x be hours, y be miles. The average speed is a slope, so that would be 540. And then we're going to let the point be 1.5 and 8. So I said after 1.5 hours, his plane traveled 810 miles. The average speed of travel is 540. That's where they got those numbers from. So we'll take our point slope form. We'll punch in the numbers. We'll put x1 and y1 in their correct positions. Again, you got to be careful. Don't swap them by accident, because y1 goes here, it's not x goes here. Be really careful on that. Okay, and that gives us an equation of this. Yeah, I'm just not going to read it. Moving on. Pause this, give it a shot. All right, a bucket of water running in a faucet fills 1 liter after 1 second, and then 2 liters after 2 seconds. Write a linear equation that represents the data. Assume the rate of change is constant. Okay, so this is actually a 2-point question here. So we have 1 liter, and it'll be 1. And then 2.2 after 2 seconds, it'll be 2.5. So we put those into our equation. So 2.5 minus 1, and then 2 minus 1 equals 1.5 over 1. And it looks like it's going, is it positive or negative? The faucet is running at this pace. So there's my, so that's going to be a positive number. Yep. No, it's going down. So the water is bucket running under a faucet. Write a linear equation to represent this data. So this will have to be a negative number. All right. Actually, that should be minus a minus, or a minus a 1, minus a positive 1. Anyways, moving on. It's got to be a negative number. So then we just pick one of these 2 points. It doesn't matter which one. We can put either one in. So we can go y, let's just go minus 1 equals negative 1.5, and then x minus 1. That's one option. Did it give us that as an option? That is not an option. So it looks like I'm going to have to use the other point. So y minus 2.5, and then equals x, and then x minus 2. Did they give me that one? Yes, they do. Keep rolling here. Write an equation of a horizontal line. So write point slope form, or using point slope form, write an equation for a horizontal line that passes through 0 and 5. So we take our point slope form. We know that a horizontal line has a slope of 0. So after we simplify it all out, it doesn't matter what's on the right-hand side. The only one that matters is on the left. So y minus 5 equals 0. And that would make total sense because y ends up on this side. If it has no slope, anything on the x is just going to be a 0 anyways. So the answer would be y equals 5 minus 0. Same concept, give it a shot. Okay, so we take our point slope form. Okay, the slope is going to be 0. And that pretty much negates whatever's on that side. So the x value doesn't really matter at this point. And so we're just going to put that negative 4 into here. Probably simplify that out to be a positive 4 equals 0. Again, careful of those negatives. All right, write an equation in standard form. Okay, so in standard form, the variables are on the left side of the equation. A, B, and C are all integers. Okay, so we take our original equation. We're going to multiply each side by 4 to get rid of that fraction, because that's just obnoxious. After we distribute that out, they multiplied this by this, and this by this. From here, we're going to subtract. From there, we've got to take 3x onto the other side. So we subtract 3x. Gives me x, a, b, and c. So the standard form of an equation is either one of these. So it depends on which one's positive, which one's negative. If you took it the other direction, Yeah, it just depends on what you did with the negatives there. At the beginning, you could have done it by -4 to make everything change. It just depends on your options, what you chose to do. Remember, standard form is ax and then by equals c. And I'll even give that to you. And go. All right, so we're trying to get it into this form. Y minus 3 equals 2x plus 4. We distribute first. 2x plus 8 equals y minus 3. I'm going to subtract or add 2 to both. Or sorry, is that a plus? Yep. So that's an equal. So subtract 2x. Subtract 2x is going to put that all by its lonesome over here. Negative 2x plus y minus 3 equals 8. I'm going to add 3 because it's not quite in this form. Gives me 11 equals negative 2x plus y equals 11. There's my answer. Keeping going. All right, almost done. All right, take this and put it into slope-intercept form. So we're looking for y equals mx plus b is where we're going with this. So we take our original equation, and then we distribute it over. This one times this one times this. Oh no, it's a fraction times a number. These cancel, and you keep the negative. So from there, we need to, I'm not quite into this form. To get it here, I've got to get rid of this to that side. So I'm going to add 5 to both sides. Simplify that out, and that gives me my slope-intercept form. Just making sure we saw that. So these would cancel. Negative 4 plus that is going to be a positive 1. So that's where they got this from. Just making sure we can see it. That's y equals mx plus b. All right, pause this, give it a shot. Okay, so I'm going to write this. I need to get it into, they're asking for y equals mx plus b. Okay, so I need to take x over, and the 2's got to go over. So let's start with the 3x minus 3x. And I'm actually going to put that first when I rewrite this. Okay, I'm going to divide both sides by 2. And you can think of it either way. You can either do it like this, and then apply it to both, which works just fine. Or you could actually divide by 2 on this one and divide by 2 on that one to give you both. So that would give me negative 3 over 2x. 6 divided by 2 is 3, which that is my equation. All right, a little geometry here. This figure shows a trapezoid ABCD with bases A, B, and C, D. So the bases are A to B and C to D is what they're saying there. So write a point slope form of the lines containing the bases of the trapezoid. So first we need to find the slopes of A to B and C to D. So that would be A to B and C to D is what they're saying there. Probably should have copied this onto this slide here. So we take our slope formula. We take the 2 points that we had for A to B. We're doing just the first one. And then the second one, surprise, surprise, they come out to 0. We could have probably just said that, but there's the math for you. So you can either use either point of x1 or y1 in point slope form. So we're going to take A to B, take our point slope form, punch in the numbers with our 0, which will cancel out, lucky you. And that gives me that side. This one's going to have the same thing because 0 is going to go in. I'm going to put this into this position, this into this position, and then whatever those are equals 0. Method number 2, you could use the point 1, negative 2. Same basic concepts. I took the other 2 points for C to D. Comes out to the same equation. Interesting. So point slope form of the equation AB is this, or A to B and C to D is this. Now we're going to write each of those equations in standard form. Which one's standard form? Take my original equation. I'm going to go put 3 on both sides. Y equals 3 is the only option we have because we got to put the constant on the other side of the equal sign. So that's as close as I can get to that because there is no AX, there is no X, and the slope is attached to Y or whatever would be on there. So we just have to take the constant to the other side. Same thing on this one, subtract it to the other side. They're being really nice to you giving these with zeros here. They might give you ones that don't have zeros later. All right, pause this, give it a shot. All right, so first thing you got to know, and this is probably the hypotenuse, is the one that's opposite the 90 degree here. So they're wanting this line. So let's make sure we know that first. Right, keeping going. So the figure shows a triangle. You write the point slope form of this one containing these here. So first I need the slope. I'm just going to guess, go on a limb here. It's going in a positive 1. Also, all of these say positive 1. So that was it. We could actually put this into our thing. 4 minus 1 and 6 minus 3, which would give me 3 over 3 or 1. We could do that, but you could also look and see that it goes up at a 45-degree angle through each point. Many options. Moving on. Looks like I need to just substitute these in. So y minus y1 would be 4 and equals 1. And then x minus x1 is 6. So it looks like the only one I got is down here because those are the numbers they used. Okay, this one write the equation in standard form of the one that we just made over here. So I'm going to grab this equation. So minus 4 and minus 6. Distribute that out. Y minus 4 equals, so I just need to take this and positive 4. Sorry, I put that extra one there. Plus 4 on both sides. Y equals x. It's going to be a minus 2. Well, that's not standard form. Standard form is AB, AX, BX, CX. Went the wrong way there. So I actually needed to, at this point, on y minus 4 equals x minus 6. I need to take that one that way and that one that way. So minus x, getting a little long here, we're going to double it up. Minus x, so y minus x equals, and then plus 4 on that, equals 2. Okay, so they actually did the opposite. They took y over and 6 over this way. So they kind of did the opposite here to get this question. So let's ignore that for just a second. We'll go over here. Y minus 4 equals x minus 6. They took y over. So I had x minus y minus 6, and then we plus 6. Plus 6 gives us 2 equals x minus y, and then the identity property to get it to that position, x minus y equals 2. There's how they got it. Moving on, have a good day.